Hello everyone and welcome back to a new Databricks video. Today I'm going to show you something very interesting. How to take a big vision AI model and use it to automatically watch surveillance video and then ask questions in natural language about what happens in that video, and all running on Databricks. So specifically, we are going to look at security camera footage and ask an AI model to check whether it sees any shoplifting happening in those videos. We'll be using a model called Qwen2.5 VL. VL stands from visual language, and this means that it can look at video frames and describe them in plain English, just like ChatGPT does with text. To run this at scale across a whole folder, not just one video, we are going to use a tool called Ray, which let us process many videos in parallel instead one at a time. And the fun part, I'll be running this on Databricks near a serverless GPU option, so that we don't have to manually configure any GPU machine and administer the infrastructure around it. I'll walk you through the whole pipeline step by step, from downloading the video dataset and running the actual video analysis and turning the results into a clean structured table that you could query just like other data in Databricks. Very interesting use case, so let's jump in. Alright, so for this video, I was actually inspired by a session which I attended when I was in San Francisco at the Databricks Data&AI Summit, and I wanted to try it by myself in my own Databricks workspace and using this vision language model. So this is where I took my inspiration from, and with this, let's jump to the demo. So in our first step, we are going to download the video data. Before doing that and showing the code, I'm going to show you first what kind of data we are looking at. There's a public data set on Kaggle, which is called Real-Time Anomaly Detection in CCTV Surveillance. And this data contains videos about different categories, for example, for assault, burglary, robbery, stealing. But the one that is interesting for us in this use case is this one here, shoplifting, which contains 50 files. So this is the dataset that we are going to download. Now I'm going to also to show you how these videos look like. One example, just to know what to expect. So this is one of the videos, a short one, where we actually see two persons in a shop that they are randomly interacting with each other. We don't know which one or if some of the person is a seller, but we see that they are interacting with each other and checking some items. Now at some point in time, one of the person is grabbing one object from the table and then putting it in his pocket. Now this is one of the examples. The others are more or less the same. This is the quality of the video that we have it at disposal, and we have to work with it. Now what we want is to put a vision language model on top of this kind of videos and answer question in natural language about what is happening in that video and about the behavior of the person in the videos. So let's dive into the code. Now for the first part, we are going to download the video from this Kaggle dataset using Kaggle CLI. For that, I'm going to use CPU cluster, no need for GPU cluster on this part. We are just going to download the data, and we are going to save that data in a volume called raw video CCTV. So we can adapt this name, not a problem. And this is where I configure the Kaggle credentials. And then this part here, I'm going to download and extract the data via Kaggle CLI. Then I'm going to build a reference data frame, do some analysis of that video, exploratory data analysis. For example, what is the maximum duration? What is the minimum duration of the videos that I have it in my data set? And I'm also going to save that reference table in my catalog under this name. So let's take a look at how this table looks like. For that, we jump to our Databricks catalog, which is called VLM demo. And I'm going to find here also my volume called data, raw videos. And if we go inside, we should find those videos in MP4 format. And the table that I mentioned before is called video file reference. Let's do a sample of that data. So this table contains metadata about those videos. So we have here the path, we have here size, modification time, and duration in seconds. Why is this important? Because this will help us in the future to, when we are going to ask the model what is happening in this video, to map the answer to the video itself and to the path. All right, so this table is important. We have it here. The next step is downloading the Qwen2.5 VL model and register in Unity catalog. Now for that, again, this time we are going to use the classic CPU compute. No need for GPU on this side. We are just downloading the model. We are not going to use it in this notebook, and register it to have it in our Unity catalog. We are going to use MLflow for that. Now if we go to Qwen2.5 VL documentation, you will find more information about this model. You can use it also for pictures, but also for videos. You can find here a couple of information more. All right, so in this step, we are downloading and register the Qwen2.5 model. This is where we give the ID. And this is the part where I register the model to Unity catalog via MLflow. So I have here the model signature, MLflow start run, and we are going to register the model under this path here. And then we set an alias so that we know that this version is production version. How does it look like in Unity catalog? If we switch to our catalog here, our catalog is called VLM demo. We go into the schema. And after that, we'll find our model here, register under models. If you want to have more information, you can go to the version itself or to the lineage. You can go to the version itself. You have here the lineage, so who created that and registered that model. It's coming from this notebook. You can find traces and so on. You can also find the model here under models. If I search for Qwen2.5, so this is the model that I registered. Great. Now make sure you have here Unity catalog selected when you search for it. Yeah, so this is 2.5. And this is what this notebook is doing. The next part is the most interesting part. This is where we are going to do the batch video querying on Ray framework. Now what is happening here, we have a couple of parameters here in this notebook, the VLM demo, the category shoplifting, input table, the table that I showed you before, maximum duration in seconds, so to 1200 seconds, production is the model, alias, the model name, the output table, and the schema. So at the end, we are going to check this video ref inference table. And how is this working? This is the part where we are going to use the GPU compute. For that, you have to go here on the right side and select here from this drop down the hardware. For this model, I used here 8xH100. And the base environment, it's already coming with some AI functions. This is really great. But you can also install your dependency and your requirements here. You can put your requirements txt and point it to this part. And at the end, you have to click here, apply. Now what is happening? First, I'm going to install some libraries. The most important one here is this import torch and VLM and this ffmpeg. Now in the next step, we are going to use the widgets here to define our parameters. And we are going to start this Ray cluster. We can find more information here. we're going to start this array cluster, which is going to help us to parallelize. And in the next step, we are going to define the inference classes. So basically, we are building two-stage pipeline inference on Ray. The first stage is pulling frames out of the videos. This can be done with a CPU. And the other one is running the actual AI model on the GPU. That's why we have here two classes, convert to prompt and Qwen video processing. All right, so here are the classes, convert to prompt. This is the CPU stage. It contains a couple of functions. It's also creating the prompt. This prompt will be used to ask questions about videos. So for every video in our pipeline, we are going to use the same prompt. And then this Qwen video processing. This is basically setting up the GPU stage actor. It's called actor. That's is the name in the framework. We have here the model weights path. That's why we downloaded the model and registered to Unity catalog. Then we have a couple of information here, max tokens, temperature. These are information or parameters relevant for every large language model. Then we are going to load our input reference table, which I showed you before. Nothing special here. I've done here estimation of size. We have 49 videos, 2.11 gigabytes match. We are doing some pre-staging model weights. So before triggering the pipeline. And in this step 7, we are building the Ray batch inference pipeline. We have here some arguments like minimum pixels, maximum pixels. This information relevant for videos, for video transformation. And at the end, we are going to trigger those functions, those classes that I showed you before. And we are going to write the output to this table, to this output table, which is in our case video inferences. How does this table look like? This is the most interesting part. If we go again to our catalog, this time to video inferences, we can sample our data from here. All right, so what are we going to see here? The same as the file reference. We see the path, the size, modification, duration, category, some FFmpeg information, but we are also going to see the prompt that was used for every video, right? So every line means one video, and the same prompt that we configured there was used for every video. And the most interesting part is this generated text. Let's check this one. So for the first video, the answer of LLM was, after analyzing the surveillance video, there is no clear evidence of shoplifting activity. Here's a detailed breakdown of the observed behavior. And then we have information about what is observed there. For example, a video description, a person observed, the behavior. If you take a look at the behavior, the individual walks around the store, examining various items on display. At one point in time, they appear to interact with the merchandise, possibly trying on glasses and inspecting them closely. And the final answer, no shoplifting activity is detected in this video. Now let's check a little bit this video. What was it? It was video number 053. We can go to our catalog. Data, raw video. And 053 should be on the last page. Is it this one? And let's analyze ourselves the video. It's 1 minute video. Let's make it a little bit bigger. So we can see here the lady is checking some items, looking around. Seems like she wants to test some glasses. And then is walking around or going out. So this is one of the video, and the LLM told us there is no shoplifting activity in this video. Now let's check also the video that I showed to you at the beginning, which should be this 033, the second one. No need to open the video anymore because we already saw it at the beginning. This is the output of the LLM. The video depicts a sequence of events in a clothing store where a man appears to engage in suspicious behavior that could be indicative of shoplifting. So it's not saying he did it, but it's indicative of shoplifting. Below is a detailed analysis of the video. Again, he's describing the sense here, what is happening between 0 and 3 seconds, 3 and 6 seconds, and so on. And the final moment, the man exits the frame of the video without interacting with any checkout or payment area. The woman remains at the display table, seemingly unaware of the missing jeans. Maybe they were not jeans, but the model saw there's something suspicious. So analysis of suspicious behavior, hiding merchandise, intentional bypassing of checkout, distracting staff, unusual handling of merchandise. So from video language model perspective, that woman was actually the staff, and he was trying to distract her. What is the conclusion? The analysis highlights the need for store staff to be vigilant and monitor customers who exhibit similar patterns of behavior. Based on the observed behavior, there is strong evidence to suggest that the man engaged in shoplifting. The key indicators include hiding merchandise, bypasses the checkout, and distracting the staff. And this is the output that is actually interesting. Now we can do the same for other videos, the same works for others, but this is how you can use a model like Qwen2 VL, which is a visual language model, to analyze this type of videos. Actually, this is very, very useful because most of the data in the company is not born structured. It's born in unstructured data, something like this, or PDF files, or some images. Imagine in manufacturing where you have a very critical component and you have to monitor that component for anomalies. All right, what you can do from here, for example, you can extract this information in a even more structured way. So structure entity, you can extract entities from it. This is the fourth notebook. So we can have here extra columns for camera view, for suspects, person A, appearance, red hoodie, hiding merchandising, underarm. These are the actions, the described actions. So you can extract this in this kind of array or JSON format. Assessment, if it's confirmed or normal, likely. So we have here a couple of parameters, how we want to do the assessment. If it's confirmed, then say it's confirmed. If it's likely or unsure, say it is unsure or likely. All right, this was the demo that I wanted to show you. It's very, very interesting. You can actually use it for other classes here. It doesn't matter if it's shoplifting. You can also test it with other anomalies detection, for example, explosion, fighting, road accidents, and so on. Very, very interesting. And if you want to check the Qwen 2.5 vision language model, you can check it on this page. I hope this was useful for you, and that's it for this time. Basically, we took a folder of raw CCTV videos, ran them through a vision language AI models using Ray for parallel processing, and we ended up with a clean delta table where each row tells us in plain English whether shoplifting happened in that video and what exactly occurred. To recap what we covered from technical perspective, we downloaded and staged the video data. We register the Qwen 2.5 VL model in Unity catalog in Databricks, and then we build a two-stage Ray pipeline. One stage for pulling frames out of the videos, and the other running the actual AI model on GPUs. And then at the end, we wrote everything into one queryable table like we saw in the demo. And we did all of this GPU transformation in serverless GPU compute, so there was no cluster to administer in the end. Now the same pattern isn't just for shoplifting detection. We can swap out the prompt and you could point this architecture at any video understanding for example, quality inspection or content moderation, you name it. Basically, the architecture should stay exactly the same. Only the question you ask the model might change, and you adapt the parameters here and there. I hope this was useful for you. If you found this video useful, subscribe for more database content. And until next time, enjoy Databricks.